In this online lecture, we're going to talk about how to name alkyl halides. And these are just simply alkanes with halogens attached to them. So what you see here is definitely an alkyl halide. And naming these is no different from all the other steps we followed in naming all the other molecules. So step 1 here is to find the longest chain of carbons and making sure that one of the carbons in the chain has the halogen attached to it. So that would be this right here, and that's 6 carbons in the box, so that makes this hexane. Now for step 2, the correct numbering here, we're going to treat the halogen as a substituent. So again, since we want low substituent numbers, we should number in this case from left to right. That places our chlorine on carbon 2. Now for step 3, let's circle and label our substituents. This right here is chlorine, but when he's a substituent, we change the INE ending to O. So now he's chloro. That brings us to step 4 here. Let's put the name together. The name of this molecule is 2-chlorohexane. So this is how we're naming halogens as substituents. For instance, F-fluorine becomes fluoro, and bromine, Br, becomes bromo, and iodine becomes iodo. So to make sure you got this, let's look at another sample problem here. How would you name this molecule? Well, step 1, the longest chain would be this right here, making the parent name of this molecule pentane. Now for step 2, getting the correct numbered carbons here, we could possibly number 1, 2 from left to right, or if we numbered 1, 2 from right to left, notice numbering from left to right gives us 2 substituents on carbon 2, and numbering from right to left only gives you 1 substituent. So the fact that the left to right has 2 compared to the 1, we're going to want to number from left to right in this case. Which brings us to step 3 here. Let's label our substituents. Notice we got a methyl, we got the chloro, we got the methyl down here. We're now ready for step 4. Let's place this all together. So let's create the name here, and remember we have to put the substituents in alphabetical order, and notice C comes before M in methyl, so therefore we're going to list the chloro first. So that gives us 4-chloro, and then 2,2-dimethyl pentane. So in this particular example, I'm pointing out how to number the carbons correctly when you happen to be in a situation like this. But notice, look at this next example here. Watch how the numbering of the carbons, step 2, works in this case. Let's first start with step 1 here. Our longest chain would be this right here, making the parent name of this molecule pentane. Now here it is, step 2. Watch what happens here. Technically you could number from left to right and you would get a branch point on carbon 2. And that's also true if you numbered from right to left. But notice in this case we don't have more branches on carbon 2 than the other carbon 2 like we did in the previous example. So who becomes the official carbon 1 and 2 in this case? Well, here's how we resolve this. What you do is look at each substituent. This is a chloro, remember, and this is our methyl over here. And again, you go by the alphabet. Since C comes before M, that means he has the priority, let's say, in this case. So we're going to number from left to right in this case. So that's how you handle a situation like that. Now let's just finish this off here. Step 3, we've kind of already circled and labeled our substituents here to figure out the numbering. So we can move now to step 4. Let's put this all together. And again, the substituents are going to go in alphabetical order in the name. So we'll list 2-chloro first, and then we'll put the 4-methyl pentane. Now let me show you another sample problem that's kind of quirky here. Look at this molecule. Step 1, let's try to name him. That would of course be the longest chain. It's 2 carbons, so of course this is some kind of ethane. And then of course moving to step 2, we only have 1 substituent here, so we would call this carbon 1 and the one next to him there carbon 2. Which brings us to step 3. The substituent here is chloro. And now to step 4, you would think to put 1-chloroethane. But for this particular case, the 1-chloro is redundant, so this is actually incorrect. And the reason why is because simply there's no such thing as 2-chloroethane, which is why we don't have to emphasize 1-chloroethane. Let me show you what I mean by that. Remember, here's our molecule. If we were to move the Cl over to here, you wouldn't call this 2-chloroethane because moving the chlorine there changes the numbering. Now this becomes carbon 1 and this becomes carbon 2. So there's no need to emphasize that the chlorine is on carbon 1. Therefore, the name of this molecule is just simply chloroethane. And while we're looking at this, let me just make sure you know his common name. He's also called ethyl chloride. Now, careful with this. This redundancy is only for this particular case. For instance, let's say you had this molecule right here. If you were going to number him correctly in step 2, this would be the correct numbers. And the name of this molecule would be 1-chloropropane. In this case, you need to put the 1 because technically there is such thing as 2-chloropropane. That's if, of course, if you move the Cl over to here, now the name of this molecule is 2-chloropropane. However, notice there happens to be no such thing as 3-chloropropane, because if the chlorine is here, then in step 2 your numbering would be this way. And the name of this molecule, of course, is 1-chloropropane, which is identical to the first molecule we looked at here. So careful, there are some times when you need to put the 1 in the name. Let's look at another example here. Let's go skeletal structure here. What is the name of this compound? What I want to show you is that even in the skeletal form, you can still quickly name a compound. Now remember, typically on an organic chemistry test, structures are listed in skeletal form, so we do want to make sure we know how to name molecules this way when they're presented to us in this format. So let me show you here. Step 1, let's find the longest chain. It happens to be this right here. We've got 4 carbons, so that makes this parent name butane. Now, numbering the carbons here, you can go either way because this molecule is symmetrical. So 1, 2, 3, and 4 would be this. Which brings us to step 3 here. Circle and label our substituents. We have these 2 right here. They're both called bromo. So we're ready now for step 4. Let's put them all into the name here. It would be 1,4-dibromobutane.